Alright, so today is December 1st, and we're going to be completing the square when a equals 1. So whenever that first coefficient is 1, we're going to complete the square for today. And I will be honest with you, completing the square is not one of my favorite things to do, but that is only because I forgot how to complete the square, and then in college I had a professor for, I don't remember, differential equations or something, and he assumed that we knew how to complete the square on a final exam, and we never reviewed that process, and so I missed that question on the final just because I didn't remember how to do it. So I kind of have a personal vendetta out for completing the square, but it is not a difficult process. So I'm going to show you how to complete the square when a equals 1. So on this left side we have the algebra, so just showing you with a general form, and then on the right we have an example. So we want to write as ax squared plus bx plus something. So we don't know what that something is yet. In order to find it, we're going to take b and divide it by 2. So on our example, b is 6. We'll divide 6 by 2, and then we'll square it. So 6 divided by 2 is 3, and 3 squared is 9. And then we see that in the parentheses, when we're rewriting it as a perfect square, we have x plus b squared, x plus b over 2, and then that's all squared. So our b over 2 was 3, so over here on the right side we have x plus 3 squared. So we're going to do the same thing. We have x squared plus 10x plus something. So in order to find what that something is, I'm going to divide 10 by 2, I get 5, and then we'll square that, and I get 25. Well, let me rewrite that. So then 5 squared equals 25. That's what goes in that blank there. And then when we rewrite it, we have x plus our b over 2, which was 5, and then that's the same thing as x squared plus 10x plus 25. So we're just creating a perfect square trinomial, and then writing it in factored form basically. So on number 2, we'll do the same thing. We want to take that second number and divide it by 2. So negative 2 divided by 2 is negative 1. Then we're going to square that number. And see, they start with a plus every time, and that's because when we square that number, we're always going to end up with a positive. Any number squared is a positive number. So that's why we always have that plus on the end there. So the number that goes in there is a 1. And then for our binomial, we have x minus 1, whatever our b over 2 was. And then that's the same thing as x squared minus 2x plus 1. Let me square those so we can see where our answers are. So then on number 3, we have a c term. So whenever we do have a c term, it's going to take a little bit of a different turn. We want to move everything over, not everything. We want to move that last number over so that way we can write it as first term, second term plus something, just like in 1 and 2. And that equals 27. Since we moved it to the other side, it changed signs, plus that same something. So remember in algebra, whenever you do something on the left, you have to do it on the right. So if we're adding something on the left, we're adding that same number on the right. So our c term would be 6 divided by 2 squared. So 6 divided by 2 is 3. 3 squared is 9. And remember, when we write it as a binomial, we have x plus b over 2, so x plus 6 divided by 2, and then all squared. I added 9 on the left, so I'm going to add 9 on the right. And so that equals 36. So x plus 3 squared, move the 36 back over, equals, and now that's the same thing as saying x squared plus 6x minus 27. So you can complete the square even if it's not a perfect square, like in 1 and 2 where we were creating a perfect square. We're still able to do it when we don't have one by moving that c term to the other side of the equal sign. So we'll do it again on number 4. Number 4, we're going to move that 8 over by changing its sign. So x squared minus 6x plus something equals negative 8 plus that same something. So I'm going to divide negative 6 by 2. That gives me negative 3. I'm going to go ahead and write that in the binomial. And then I'll square it and put that into the trinomial. So that's my c term. Goes on the left and the right. Negative 8 plus 9 is 1. So then x minus 3 squared minus 1, we're moving it back to the other side, is the same thing as x squared minus 6x plus 8. Now on number 5, we have a number as c, and we also have a number on the right side. So I'm going to subtract that 11. So I'm still moving it to the other side. So that way I can have x squared minus 10x plus something, and that equals negative 14 plus that same something. I'm going to divide negative 10 by 2. Gives me negative 5. I'm going to square negative 5. That gives me 25. And then on the right I have negative 14 plus 25, which is 11. So then I'm going to move that 11 back over by switching its sign. So x minus 5 all squared minus 11 is the same thing as x squared minus 10x, and then plus 14. So the reason I wrote plus 14 is because I wanted it to equal 0. So I moved the negative 3 over to the left side. If you don't want to do that, then you could have just said that that was your answer, and that would have been okay. Number 6, we have the same type of situation where there is a number on the right. So I'm going to move c over, and I get x squared plus 12x plus something equals negative 8 plus that same something. 12 divided by 2 is 6, so x plus 6 squared. 6 squared is 36. On the right side we have negative 8 plus 36, which is a positive 24. I'm going to move that 24 over to the same side. So x plus 6 squared minus 24 since it's moving. And then that equals the same thing as x squared plus 12x. And I'm going to move that 5 over this time, so plus 8. Again, if you wanted to just write that part as your answer, that is okay. So we're able to create perfect squares inside of the problem. Here's our perfect square by completing the square. So for your homework, you have 1 through 6. I'll probably post the answers to 2 of them, just that way you have enough practice with completing the square. And then tomorrow we will be completing the square when a is not a 1. So just like in factoring how we can have something in the front, it's going to be the same with our completing the square. So I'll see y'all tomorrow for that topic.